Hi, my name is Alexander Savage, one of the architects on the Coherence engineering team. In this presentation, I will talk about new asynchronous name cache API that was introduced in Coherence 12.2.1. In the first part of this presentation, we will cover the reasons for the introduction of the async API, as well as Java 8 features that allowed us to implement it, completable future. We'll then briefly discuss asynchronous entry processors and aggregators, the low-level building blocks that the async API is built on. And once we have the basics covered, we'll look at the async name cache API, and I'll run a demo that shows performance gains for basic operations that we were able to achieve by adding async API to Coherence. We will then take a look at another demo, which is much more complete application, web crawler, and compare and contrast synchronous and asynchronous implementation of the crawler, which will not only highlight performance differences, but will also show you how easy it is to write asynchronous applications using Coherence, async API, and Java 8 completable future. In the process, you will also learn how to implement an HTTP proxy on top of Coherence in less than 200 lines of code. So let's get started. So the first question is, why did we decide to implement async API? The primary reason for the addition of async API is increased efficiency. Many Coherence applications unnecessarily block application threads when performing basic operations such as gets and puts, simply because writing correct multi-threaded clients using synchronous API is too cumbersome. The combination of a proper non-blocking asynchronous API and Java 8 completable future makes the implementation of non-blocking Coherence clients much easier and allows us to achieve some truly monumental performance gains, as you'll see in a demo in a bit. So let's talk about completable future for a second. If you're not familiar with it, it is one of the major new features of Java 8 that ended up somewhat under the radar and didn't really receive nearly enough attention, mostly due to popularity of other Java 8 features such as lambdas and streams. And while popularity of lambdas and streams is very much deserved, completable future is also a very powerful new feature. What completable future does, unlike standard future interface that we had for a while in Java, is actually it enables easy compositions of asynchronous tasks. So it's not just you submit work for execution, then you can either let it go or block on it, such as calling future get. With completable future, you have a number of methods that allow you to compose multiple completable futures, and they all return a new completable future. So for example, you have static all of and any of methods. So you can pass an array of completable futures to both of these methods, and they will give you a future that completes when either all of the futures in the array or any of the futures in the array is completed. Then you have methods such as then accept, then apply, then combine, then compose, then run, when complete, handle, which are different variants that allow you to execute a piece of code or to apply a function to the result or to compose multiple, to turn asynchronous execution into sequential execution using then compose, for example, etc., etc. The initial completable future can be created from a runnable or supplier. There are static factory methods that allow you to do that on the completable future itself. And as you'll see later, Coherence API gives you a really easy way to get completable futures, because basically all the methods on the async name cache API return completable future. This is brief intro, but you can find a really good introduction to completable future at the link provided on the slide. So if you're not familiar with it, I definitely suggest that you take a look at the tutorial that is available on that URL. For now, let's look at a couple examples. In the first example, we're basically creating completable future. The goal of the example is to fetch a page from a specific URI and then process the page. When we say process the page, it means parse the page, find all the links in it, and go fetch those links recursively and do the same for all of them. So in this case, we are creating a completable future that starts by fetching a page from a specific URI, and then once the page is retrieved, it calls process page method that does parsing and processing of the page. In the second example, we do the same thing, but we actually do it not for a single URI, but for multiple URIs. So we have a set of URIs, we create stream from that set. And then in the first map stage, we create completable future, just like in the first example. We create a completable future, supply async, and then we provide a supplier that calls fetch page for a given URI. And then in the second, this stage basically returns a new completable future, right? And then in the second stage, we then compose on that page future and call process page on it. So it's exactly the same code that we have in the first example. And then finally, because we are now processing multiple things, we will have multiple process page futures. And we convert those to array using toArray completable future : new. And then finally return completable future all of tasks based on the array that we created. So this gives you a really easy way. Combination of completable future and stream in this case makes it really easy to process number of tasks and to combine them using completable future all off into a single future that you can then wait for or add some more and compose some other tasks on. So that's as far as we'll go regarding completable future. So now let's look at some of the building blocks that Coherence provides that allowed us to implement async API. The first of those is asynchronous entry processors, which were introduced in Coherence 12.1.3, but were significantly improved and extended in Coherence 12.2.1. In addition to asynchronous entry processor that handles multiple entries at a time and is basically used with invoke call, we now also have single entry asynchronous processor, which is used with invoke and is used to process a single entry. So things like gets and puts will use single entry processor, while things like get all, put all, etc. will use asynchronous entry processor. And then finally, we also have streaming asynchronous processor, which doesn't really return anything, but basically gives us a way to process individual results as they stream back. So instead of getting a map of results, as is the case when you do invoke call with a regular entry processor, you will basically just get a notification that processing is complete. And in the meantime, you will get individual entries for each of the results that would be in the final map. Asynchronous entry processor can be easily converted to completable future now. Basically, if you execute a code in this example, you basically create an entry processor, you call cache invoke on a key passing the processor in, and after that call is made, you can basically call async get on the processor itself. You can call get completable future method and it will return completable future, which might or might not be completed already. So once you have that completable future, you can do anything you can do with completable future, compose it with other futures, etc. The second building block is asynchronous aggregator, which is new in 12.2.1. This is something we've added to complete the foundation for the async namecache API. And just like entry processor, it can also be converted to completable future. So if you create an instance of it and call cache aggregate method with it, after that you can call get completable future on it and you will get completable future back. Both of these low-level features, entry processors and aggregators, can be used directly, but there is rarely a need to do so. I'm sure you'll agree, once you see the examples, that the higher level async API that we implemented on top of them makes our life much easier and makes the implementation of async applications on top of Coherence much simpler. So let's take a look at the async API and then we'll move on to the demos. As I said, the async API is new in this release. It's introduced in 12.2.1 and it is built on top of async entry processors and async aggregators, but it makes operations much simpler. So instead of you having to create instances of appropriate entry processors and get completable futures from them. You can simply call cache.async on your standard name cache that you're already familiar with. You can call this new async method, and then you basically have most of the methods that you have on the name cache itself. So you have methods such as invoke all, aggregate. You also have methods such as get, put, remove, get all, put all, etc., etc. Pretty much all the methods from the name cache are available on the async name cache with few exceptions. The major difference between these calls and the calls on a standard synchronous name cache API is that all the methods on the async name cache return completable future. So that allows you to compose asynchronous operations easily. Once you call the method, you get completable future back, and then you can merge it with other completable futures. You can block and wait for it to complete, etc. So you don't have to create completable future yourself. Basically, any operation on async name cache API will create one for you that you can use from that point forward. In addition to that, as I mentioned earlier, we provide a streaming API. All bulk read operations such as get all, entry set, key set values, as well as invoke all, also have the streaming variants. And those usually come in two shapes, depending on what we are returning. So for get all and entry set, for example, which return map entries, you will see these two variants. For key set and values, there will be only one, because they only return one thing. So the first variant basically allows you to specify a consumer that will be called with a map entry that contains key and value for each result of the get all operation. And the second variant allows you to specify by consumer, which basically also gets key and value, but it makes it a little bit easier to code against if you don't need map entry itself. So we provided both of those, and the main reason for the streaming API in general is to basically allow you to consume a stream of partial results without collecting them on the client or on the server for that matter, because if we are streaming results back to you, we know we don't need to collect them. It's going to save some memory on the server, it's going to improve performance, you're going to get the results on the client, process them without ever having to collect them into local collection. And all of these methods, as you can see, return completable future void, because there is because we are not collecting, we have nothing to return really. Once we have called the callback for each of the partial results, the only thing that we do is complete the future that returns nothing, just to let you know that we're done, that there is nothing more. And at that point, you have the future that can be used to compose. That can be composed with other futures.